Thursday, week 11. Another week, wrapped it up. Cyber Defense Tuesdays. Right now we're going to go at meeting at 12:30, MH216. Yeah, and we might move that to 229 on some days. So, scaling, we talked about the course. The exams are on for 3 takes, and they're on until the end of the term. The chapter exams. Students, you need to get going on the packet tracer, the skills, practice skills ones. Those count. And remember the Dirk rule. Okay? But you need to get going. There's one on the first term, one on the second term. First course, the second course, there might be 2 for the second course. And then there's at least EIGRP and OSPF. Okay, so you want to check those, let me know if there's questions. The skills-based, I gave an update, and so we want to wrap that up next week. We have EIGRP skills-based also that we want to set up. And we'll talk more about that next week. And then we covered a little bit about OSPF and a little more about learning. So, OSPF, link state, distinguishes it from, that's the big difference there, where EIGRP is distance vector. Right? Right. So, here in this scenario we have, we talked about learns link state will get the entire topology of all the connected routers. So we're going to do, they start at single area, so we have all these routers in here in single area, and as they connect they'll learn the entire topology. Okay, so we talked about that already. I'm not going to repeat a bunch of that. And so then what you can do though is you can create an area and an area. Now they'll learn everything in here, and this border router is going to connect your areas. Here they'll learn everything in this area, and this border router is going to connect the areas. Okay, all areas must connect to area 0. There is an exception. You can bounce through an area, but we're not going to talk about that right now. Area 0, the number 0. Okay. Concerning the skills base. Okay. Let me run through the objectives again. You have a router connected to another network. This would be the address to ping to, or default gateway inside that network. And that network is a 172.21.0.0/16. So I manage that network. So I did an example where I'm connected to that network. So this is the address I used, that .1 right here. If you want to look at this, it's used in the other class, but if you wanted to, this is, let me get it here. This is device 18. Okay, so you can go in and look at that. I also, actually it's pretty close, except this device down here for me, this is actually device 30. Here, let me get that here. That's DEV31, but that one has a number of different networks connected to it. Routing between them. It's got four switches connected to it, and routing in between those 4 switches. I didn't want the students to be dealing with VLANs at this point, but it's similar. It would be similar, and you can take a look at it. Okay. We did an example of static. This was Chris M. Static NAT. Okay, Chris McDowell. This was an example of his. So let's go back to the objectives. You got to be able to do NAT. You'll need a NAT pool that doesn't include your server addresses and so forth. This and this address here. And then you can set up some static NAT for those, like here and so forth. So, another part of the objective, can you NAT out? Okay, DHCP in a multi-layered switch, can you do that? Okay. Can we have ether channel here? And we seem to be doing well there. You have the different VLANs. Okay, so you have the different VLANs down here, and so our goal would be to be able to hook on a PC. The PC would get an address and then have connectivity out to here. And if you get to here, it should be able to get to the internet. If not, that's an issue I've got to fix coming out of that network. Okay. Another couple things you got to remember, you want to put an IP address in your management down here and make sure your VLANs are actually configured on this switch and so forth. That's it for today. Make sure you let me know if you have more questions or concerns.